It takes 284.4 years for Pluto to orbit the Sun, a journey of about 23 billion miles. How fast does Pluto orbit the Sun in meters per second? Now, hopefully you'll never have to really do a problem like this, but I want to show you this because this introduces the idea of dimensional analysis. Here we're dealing with years, we're also dealing with miles. We're ultimately going to get like a speed value of miles per year. We have to convert that into meters per second. So already there are 4 different units of measure involved in this problem. And when you have a lot of these different units of measure or dimensions, it's useful to do a dimensional analysis, which is what I'll show you how to do today. First thing you want to do is draw yourself a long horizontal line, and you're going to use this to keep all the different units of measure accurate. So first we've got 284.4 years. We'll just put YR for years. I'm going to draw a line, okay. Now the distance is 284.4 years per 23 billion miles. So 23, we're going to write this in scientific notation. So we'll say 2.3 times 10 to the power of 10 for 23 billion miles. Now here's where it gets interesting. First we're going to try to convert the years into some other unit of time. Oh wait, miles. I'll put an MI for miles down here. Alright, now first we're going to try to convert the years into some reasonable things. So now in a year, we know, here's a trick of making conversions to different units of measure. We know that a year is 365 days. So if we write 1 year over 365 days, this actually equals 1. And so if you multiply anything by this value, you're going to get the same number. So without changing the ultimate value, we can say 1 year over 365 days. Let me switch this over. I already realized a mistake I've made. So just to make this a little bit simpler, since we're going to do ultimately meters per second, we should have the distance on the top and the time on the bottom. So let's draw another long line, and now we're going to start on the bottom with, we'll start with miles, 2.3 times 10 to the power of 10 miles, and we're going to have 284.4 years down here. Now instead of starting with the time units, we'll start with the distances. We're going to convert the miles into meters. So 1 mile is approximately 1.6 kilometers. So then we'll say 1.6 kilometers over 1 mile. And remember that if we have 1.6 kilometers divided by 1 mile, since the 1.6 km is equal to 1 mi, we're multiplying this whole formula by 1, so we're not going to change the value. So 1.6 kilometers over 1 mile. And now we're going to convert the kilometers to meters. Remember that 1 kilometer is equal to 1,000 meters. Now we're ready to do some work. Now you'll notice I put miles, we started with miles per year up here. Since miles are on the top, when we start to do our conversions, we put miles on the bottom. So 1 mile is equal to 1.6 kilometers. To convert kilometers to meters, again, we're going to put kilometers on the top, so now we're going to put kilometers on the bottom. So we have 1,000 meters equals 1 kilometer. And now, a lot of these units will just cancel out. So km, we can erase that. Kilometers, that cancels out. Miles right here, and miles right there. So now what we've got left is 2.3 times 10 to the power of 10 times 1,000. Now remember, 1,000 meters, 1,000 is the same as 10 to the power of 3. So if we multiply these, we're going to have 2.3 times 10 to the power of 10 plus, or actually times 10 to the power of 3, means we have, at the end here, we're going to end up with 2.3 times 10 to the power of 13 meters. And then down here we've got the same numbers as before, 284.4 years. So now we've got 2.3 times 10 to the power of 13 meters per year. Now we know the speed in meters per year. Now we have to convert the years into seconds to find out how many meters per second this planetoid is moving. So let's move down here. Let's set this up again at the bottom. Now we've got 2.3 times 10 to the power of 13 meters per 284.4 years. Now again, the secret is we're going to multiply these by things that ultimately equal to 1, so that we've got a year here. Now 1 year is 365 days, so we'll say 1 year times 1 year over 365 days. And now a day has 24 hours, so we'll say 1 day, 24 hours. And the trick to using this form of dimensional analysis is that you always, whatever number was on the bottom, you put it on the top in the next step, and whatever number is on the top, whatever value is on the top goes on the bottom. So days on the bottom, days on the top. Hours on the bottom, so now I'll put 1 hour on the top. 1 hour equals 60 minutes. And now I put minutes on the top, so 1 minute equals 60 seconds. And now ultimately, here's a quick trick. We want our final answer to be in meters per second. So we want to make sure that meters are on the top, which they are right here. We got our meters. And that seconds are on the bottom, which they are right here. So now let's cancel out anything that can be canceled. So year cancels out. This year gets canceled out. Days, days, hour, hour, minute, minute. Now I just do the math. And we've got everything on the top gets multiplied by 1, so we still end up with 23 or 2.3 times 10 to the power of 13 meters. And now we're going to do some math here. So let me bring out the calculator. So the answer we ultimately get is 2.3 times 10 to the power of 13 meters per 8,968,838,400 seconds. Now let's round this up just to make things simple. 2.3 times 10 to the 13 meters over 9 times 10 to the 9th seconds. Ultimately, Pluto is orbiting the Sun at 2.5 times 10 to the power of 3 meters per second. But the key of the reason for doing all this was to show you how this dimensional analysis works. So remember, what we're trying to do here, the goal is just to keep all these different units of measure straight, to make sure we are converting things correctly. I'll come up with some more examples of this, as they apply to physics and biology and chemistry in another video. Thanks for listening.